In this video, we will look at a grade 11 term 2 SBA in mathematics. Now this will be specifically focused at difficult questions with trigonometry and difficult questions with Euclidean geometry. Let us jump right in. Our first question says, if minus 3 sine beta minus 2 equals 0, and beta is an element of 0 degrees to 270 degrees, use a sketch in the correct quadrant to determine the value of 1 plus tan squared beta without a calculator, and this will be 5 marks. Do yourself a favor, pause this video, try and solve it quickly, push play, and join us. Now, as soon as you see in a trigonometric question where they say use a sketch in the correct quadrant to help you solve it, draw a cast diagram. Alright, or a Cartesian plane specifically. Now, the correct quadrant is a giveaway here. It's a guideline or it's a pointer to tell you what they are looking for first. And there are two things that help you solve it. Number one is your equation, and number two would be your limit. Using your equation, we see minus 3 sine of beta minus 2 would equal 0, right? And if you isolate sine of beta, you get 2 over negative 3. And if you recall, sine of beta, or sine of any angle, has the ratio y over r. Very important, r is never ever negative. R is actually the radius of a circle. So, what we could actually do is rewrite that as minus 2 over positive 3. So our y is negative. The main reason they give you that information is to tell you that sine is a negative. Okay, and if we recall, we have the cast diagram that we use to summarize ratios that are positive on the Cartesian plane. And we recall, where is sine going to be negative? Well, sine is negative in quadrants 3 and quadrant 4. Okay, now what else do we have? We have this limitation. Beta is an element of 0 degrees to 270 degrees. And if we take it a step further on our cast diagram and we recall our angles, we have 0 degrees, we have 90, 180, and 270. Which means they're telling you you could either work in quadrant 1, 2, or 3. Now, where are you doubling up? We double up here in quadrant 3. That means that is your correct quadrant. That is where we are supposed to be working. So, let's draw our radius here, our arc. If you have not yet seen the trigonometric videos on the whiteboard essay, let me help you out quick. We always close these triangles on the x-axis to form a right angle triangle. And if you carry your labels over, what is y? Well, we just saw it over here. Y is negative 2 and r is 3. Now we have a right angle triangle. We have our hypotenuse. We have our vertical side, or our opposite side. And how do we get the missing x value? Well, we know using Pythagoras, x squared equals r squared minus y squared, which means x is the square root of r squared minus y squared, which equals the square root of 3 squared minus 2 squared, which in turn equals the root of 5. Okay. However, if this is our origin, and we are working on this side of the origin, then this is a negative x, so it's negative root 5. Alright, now, you have only answered 3 of the 5 marks. First one, for isolating sine. The second one, for finding the correct quadrant. The third one, for plotting the points correctly in that quadrant. You still need 2 marks. So, let's go and answer the actual question. Find 1 plus tan squared beta. And now, if you recall, tan of beta, or tan of any angle, has a permanent ratio. That ratio is known as y over x. Alright, so I want to now replace tan of beta with its ratio, y over x. And what we then get is negative 2 over negative root 5. And don't forget the square. Solving that, well, if you recall your laws of exponents, the 2 multiplies in with the exponents of both, meaning you have negative 2 squared, so we have 1 plus negative 2 squared is 4, over negative root 5 squared is just 5, and that becomes, what's 1 plus 4 over 5? Becomes 5 over 5 plus 5 over 5 plus 4 over 5, which in turn gives you 9 over 5. And that is your next 2 marks, 1 for substitution, 1 for solving. Total of 5 marks. Alright, question 2 for a total of 6 marks. If cos of 75 degrees equals m, express each of the following in terms of m, showing all your working. We get question A, B, and C. the way this would be 6 marks is if each counts a total of 2 marks. Alright, now whenever you see M or P or a letter, whenever they give you a trig ratio with an angle equals to a singular letter, I would like you to do yourself a favor and draw a right angled triangle immediately. This is going to help us. Alright, and you can choose any one of the angles to be our reference angle. I'm going to choose this one over here, which is our 75 degrees. Now, if you recall, we are working with cos. They gave us cos of 75 degrees equals to m, which means we technically have cos of 75 degrees equals m over 1. And our cos ratio always gives us the adjacent over the hypotenuse, also known as x over r. Alright, so if adjacent here is m and r is 1, we can use Pythagoras to solve our missing side, our opposite side. And using Pythagoras over there, we get y squared equals r squared minus x squared, which would equal 1 squared minus m squared, but that is still y squared. So to get y alone, we have y equals the square root of 1 minus m squared. And this belongs on this side of the triangle. Okay, we have not received any marks yet, so let's do question A immediately. They want us to find the value of cos squared of 105 degrees. Alright, but let's take a moment to look at our angles. That's 105 and that's 75. Can we get that angle expressed in terms of 75? Well, if we remember our reduction angles, we get cos of squared of 180 degrees minus 75 degrees. And that will actually equal 105 degrees. Well, fantastic. Generally, when we do this, we look at positives or negatives. Alright, this is in the second quadrant, which means cos should be negative here. But if we have a negative squared, it becomes a positive. Remember? So this would still be cos squared of 75 degrees. Which means if cos of 75 equals m, cos squared of 75 would simply just be m squared. To explain that further, cos of 75 equals m. Well, if we square the left-hand side here, we would need to square the right-hand side. Let's move on to the second. Moving on to question B. They have asked us determine the value of sine of 15 degrees in terms of m if cos of 75 degrees equals m. Well, we need to get sine of 15 to cos of 75. How are we going to do that? Well, if you recall, 15 is actually equals to 90 degrees minus 75 degrees. Haha. So, if we had to get that as a cofunction, we get sine of 90 degrees minus 75 degrees. And that actually equals 15 degrees. Well, fantastic. And if you remember, cofunctions relies on quadrants of the current function. So sine is now in the first quadrant, which means it is positive. Therefore, our answer would equal positive cos of 75 degrees, which means this is actually just equals to m. Alrighty. And mark allocation, well, first for your reduction, second for your m. And reduction being cofunction reduction. Right, let's move on to C. Now, question C is a sneaky one. They want tan of 15 degrees in terms of m if cos of 75 is m. Now, most of you immediately are saying, identity. Sine of 15 degrees over cos of 15 degrees. And you know what? You're right. But remember, our angle here is 75 degrees. And many of you are saying, well, we've already solved sine of 15 degrees in question 2. Well, yes, we have. That was m. And if we take it further, well, what about cos of 15? Now we get the, oh, wait, what now moment. Look at the angle. It's very difficult to change 15 to 75 without using cofunctions. So, let us go back to our triangle. Alright, if you recall, we were using 75 degrees. And if you do sum of angles in a triangle, if you say 180 minus 90 minus 75, you get 15. So our missing angle is now 15 degrees. And if you consider cos, which is adjacent, so let's say cos of 15 degrees would equal adjacent over hypotenuse, correct? And that would technically be our adjacent to this angle is this side. So we now have root of 1 minus m squared over 1. And if you go put it over here at the bottom, we have the square root of 1 minus m squared. This is only 2 marks, so you don't need to take it further. You will get 1 mark for that and 1 mark for this. There we go. Question 3. We have reduction formula. Now these questions always count a lot of marks. Let's read through the question first. It says calculate the following without the use of a calculator. Don't play games. We can see when you use calculators. Alright, so let's just use our steps and go as far as possible. They say here sine 300 degrees times cos of negative 395 minus cos of 210 times sine of 235 over tan 150 times sine 775 plus cos of negative 30 degrees times cos of 215 degrees. Now, very, 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 very important. When you see a minus or a plus separating your trig ratios in the numerator or the denominator, that means you need to factorize. Which means when you are looking at your reduction formula, example here being cos of negative 395 and sine of 235, try and make something the same on the left hand side and the right hand side to take a highest common factor out. Alright, consider factorizing whenever you do your reduction formula. Now, when you are deciding what goes where, I just want to remind you of your CAST diagram. So C, A, S, and T, and the angles that go with it. So let's go through this quickly. Firstly, we need to identify sine of 300 is in the fourth quadrant. Sine is negative there. Alright, cos of negative 395. Well, we'd have one full revolution going the negative direction, which would be 360, and then going another 35 degrees is in the fourth quadrant. Then we have cos of 210, that is the third quadrant. Sine 235, third quadrant. Over here, tan 150, second quadrant. Sine 775. Well, one full revolution is 360 degrees. Two full revolutions is 720 degrees. And that is going the normal way around, anti-clockwise. Then we have another 55 degrees. So we're in the first quadrant. Just to show you on the Cartesian plane, we have one revolution, two revolution, plus 55 degrees. We're in the first quadrant over there. Then we have cos of negative 30, that is the fourth quadrant, and sine of 215, which would be the, sorry, that is cos, not sine. Cos of 215, which is the third quadrant. Alright, take a breath. No, I'm joking. Let's go on quickly to see the sine in the fourth quadrant, negative. Cos in the fourth quadrant, positive. Cos in the third quadrant, negative. Sine in the third quadrant, negative. Tan in the second quadrant, negative. Sine in the first quadrant, positive. Cos in the fourth quadrant, positive. This is all based on our cos diagram, eh? And cos in the third quadrant, negative. Right. Now, let's go and write reduction formula out. And the plan is to have something to factor out. Now, the first one, sine of 300. Now, when you're considering your reduction formulas, try and remember your special angles. 30, 45 degrees, 60 degrees. You won't always be able to use these angles, but they are a useful guideline. So let's start. Sine of 300 could be written as sine of 360 degrees minus 60 degrees. Haha. Times. Cos of minus 395 would actually be written as cos of minus 35 degrees. Okay, now we have our very important minus over there. For further help, I'm just going to put the first product in square brackets. Okay, now let's look at our second product. We have cos of 210, which could also be written as cos of 180 degrees plus 30 degrees. 180 degrees plus 30 degrees. And I just want to say goodbye to our little cos diagram here before it's in the way. Fantastic. Alright, and sine of 235. Now, we need to try and remember we need a similar term to take out our highest common factor. We need a common factor. We have cos of 35. We have sine of 235. Can we not go write that as a cofunction? So let's try. Sine of 270 degrees minus what? 270 minus what will give me 235? Well, minus 35 degrees. And I just want to put this in brackets just so that we can remember we need to factorize. Alright, and that is all over our denominator. We had tan of 150. Well, that in terms of special angles is nice and easy. We have tan of 180 degrees minus 30 degrees. Sine of 775 we discussed earlier would be in the first quadrant. That would actually be sine of 55 degrees. This might be slightly tricky, but let's leave it as sine 55 for now. Sine of 55 degrees, and then we had plus cos of negative 30. Let's just leave it as that for now. Cos of negative 30 degrees multiplied with cos of 180 degrees plus 35 degrees. Aha, now we start seeing something, but before I carry on, I just want to put square brackets around the multiplication or the products, just to draw our attention to the possibility of factorizing. And of course we need to set equals. Okay, let's look at our second step. Let's get the answer to this. Just a quick reminder, we did discuss that the answer to this would be negative, the answer to this would be positive, the answer to these two would be negatives. We had a negative, positive, positive, negative. Okay, let's go and write this out. We will now have negative sine of 60 degrees, I'm just going to keep my square bracket there, multiplied with a positive cos of 35 degrees. Close the bracket, minus. Now, a minus times a minus will give us a plus, so I'm just going to write the answer to that there. We have negative cos of 30 times negative sine of 35, sorry, negative cos of 35. But the negatives cancel out, so I haven't written them in. To show you here, a negative multiply negative gave us a positive. So I should have had a negative and a negative there, but we multiplied them out. Do you see now I have a cos of 35 and a cos of 35 that I can factor out? That is the goal that we need to bear in mind. And this is all over the denominator of negative tan of 30 degrees multiplied sine of 55 degrees. Let's put that in brackets quickly. Plus cos of 30, which we said would be a positive. So positive cos of 30 degrees multiplied a negative. Let's put this in brackets quickly. Negative cos of 35 degrees. Now, when you factor something out in the numerator, you generally want to factor the same thing out in the denominator so they can cancel out. You want to get rid of them. They are the one thing you do not want to have left behind. Why? Our goal is to always have special angles so that we can substitute the values in and actually determine a value, especially if we work in for 8 marks. And to show you here, you only have 3 of those 8 at the moment. This could be considered a 4th mark, but it is incomplete at this current moment. What we can do is we can change the sine of 55 to something in terms of cos of 35. And that will unlock the entire problem. Let me show you what I mean. If we could change this whole thing, well, not the whole thing, just this bottom term of sine of 55, we would get the following. You would get sine of 90 minus 35 degrees. And applying that cofunction, we could see that would become cos of 35 degrees. Like this. Therefore, we have a highest common factor that will help us with exactly what we need. So applying the HCF factorization rule for the numerator, we get cos of 35 degrees, and then we write down what's left, right? So minus sine of 60 degrees, bring down this minus, minus cos of 30 degrees. Alright, and applying the same rule in the denominator, we now get we now get cos of 35 degrees, and to write down what is left, well, we have minus tan of 30 degrees plus. Okay, so you see there was a minus cos 35 over here. Well, this plus 1 multiplied with that negative could actually just give us a minus cos 30. So we will not have a plus anymore, we will have a minus cos of 30 degrees. Okay, cool thing is this cos 35 and that cos 35 will now disappear. And what we can now do is we can consider our special angles. Now, special angles has a summary table as follows. You start off by writing 30 degrees, 45 degrees, and 60 degrees, your 3 special angles, and then you have x, y, and r. Now, we always start with x and root 3. So here at 30 degrees, you write root 3, 1, 1, 1, 1, root 3, 2, root 2, 2. Just memorize this, parrot it. It'll help you. Now, if you remember, sine of 60. Sine is technically y over r. So let's just write a reminder here quickly. Sine of any angle is y over r. Cos of any angle would be x over r. And tan of any angle is equals to y over x. So let's take a look. We have negative sine of 60, which means we could say minus times what is sine of 60? Well, here at 60 degrees, we have y, which is root 3, and r, which is 2. So let's simply write it in. that becomes root 3 over 2. Minus cos of 30, well, cos at 30 degrees is x, root 3 over 2. Root 3 over 2. So I'm just going to close this bracket here quickly. Over. Now let's take a look. We have negative tan of 30, so we have minus tan of 30, which is y over x, 1 over root 3. So we have minus 1 over root 3 minus cos of 30, which we just established was root 3 over 2. And now we solve. On the top, you can see you got minus root 3, so that's minus 2 root 3 over 2, according to laws of fractions, divided by, now we have negative 1 over root 3, negative 2, so that essentially would be 2 root 3 as a denominator. Okay, so that essentially would be a bracket. Now, the lowest common denominator, like we said, would be 2 root 3. So to correct here, to get the lowest common denominator on the left-hand side, we would have minus 2 minus root 3 times root 3 gives us 3. Just to show you, when you multiply out to get the LCD, here at the bottom we are multiplying with root 3, and here at the bottom we are multiplying with 2. Okay, fantastic. Now to get this in shape, we need to flip and multiply. So we have minus 2 root 3 multiplied to root 3 over. That was 2. That is minus 2 minus 3, which would give you minus 5. Okay, now to times out. 2 times 2 would give you minus 4. Well, the minus times the minus would actually give us a plus. Plus 4 root 3 times root 3 is actually just 3 over 2 times minus 5 is 10. And that would simplify to 12 over 10, which would essentially equal 1 and 1 over 5. Alright. 8 marks. Let me quickly show you where you get your marks. So we said 1, 2, 3 up here. Once you applied that cofunction 4. Then for factorizing out, you get a 5. For applying your for your special angles, you get 6. And then for solving, 7 and 8. Let's go on. Okay, question 4 is 5 marks. Prove the identity. Now, the goal with this is you always take the side with more juice. Okay, we can see the left hand side here looks very juiced up, very strong. Alright, and what we do after taking the juiced side is we try and get rid of tan, and then we wing it with identities. That's pretty much it, but that should be enough. So let's go. We say left hand side. Just a reminder that this is your left hand side and this is your right hand side. Alright, so to use up our juiced up left hand side, we have sine to the power of 4 of angle A plus sine to the power of 4 of angle A over tan squared of A. And we need to wing this that it equals sine squared of A. Alright, let's see what we can do. So firstly, I told you we need to get rid of tan for our first mark. Alright, so we have sine to the power of 4 of A plus sine to the power of 4 of A over, and now we can go and use the first identity. Tan squared A is actually equals to sine squared A over cos squared A. Okay, that's mark 1. And for the sake of space, I'm just going to carry on next to it here. Otherwise, I will run out of space on the screen. Okay, so what we see is the rule of fractions. We have any number, in this case it's sine to the power of 4, divided by a fraction. So we need to flip and multiply. To show you what I mean here, we have sine to the power of 4 of A plus sine to the power of 4 of A divided by sine squared of A over cos squared of A. And to those who might be getting intimidated by these, if you always revert back to BODMAS, you'll be okay. What do we do first? Well, handle this divide sum first. That's a very good start. You do that, and you move forward leaps and bounds. So what you'll actually see here is we are looking to flip and multiply the divide sum, and we are looking to do the divide first. So we are doing fractions in BODMAS. It's actually grade 8 and 9 maths. Sure, it's trig and and intimidating, but if you just go back to the basics, you will be okay. Let's carry on here at the bottom. So we have sine to the power of 4 of A plus sine to the power of 4 of A multiplied cos squared A over sine squared A. Now you see something cool pop up. So those of you who've noticed it, apply it along. To those who haven't, let me show you. You have sine to the power of 4 over 1 multiplied sine squared under cos squared, sorry, cos squared over sine squared. So sine squared and this power can cancel out and there's 2 left, using the laws of exponents, top over bottom. Alright, and what this essentially will equal will be sine to the power of 4 of A plus sine squared A times cos squared of A. Alright, and what we can then see is, okay, cool, there's a plus, and we have a sine 4 and a sine squared. Let's factorize. Let's try factorize. Let's just see where we get. Okay, so if we factorize a sine squared of A out, right, a highest common factor. If you just look here in the sum, we have sine squared A, sine to the power of 4. What's the highest that I can take from both? Well, I can take sine squared, so we've taken it. And what is left? Well, what's left is sine squared A plus cos squared A. And if you recall, we have a certain identity. The identity said the following: sine squared A plus cos squared A would equal 1. Is this not sine squared A and cos squared A? So that's actually 1. So therefore, what we essentially have is we have the answer of sine squared A, sine squared A multiplied 1, which is sine squared A. What was our right hand side again? It was sine squared A. So we have proven left hand side equals right hand side. So therefore we can say equals right hand side. Okay, mark allocation. Alright, we have 1 mark for applying the identity of tan equals sine over cos. 2 marks for 2 marks here for the flip and multiply. So that's already 3. And then we have 4 marks for factorizing out, and then the 5th mark here was seeing that it was 1, and there's your total of 5. Alright, let's carry on. Question 5 is fairly tricky. They ask us, determine the general solution of, and then they give 2 different trig ratios. Now that would be fine if we could bring the 1 over to the left hand side and factor out. But if we take a look at this, we have cos of theta minus 20 degrees, not a special angle, and we have sine of theta plus 40 degrees. We see that we are very limited in our solutions. Now when you get something similar to this, try and convert the one to the other trig functions. In other words, use cofunctions. Okay, so what we are going to do is we are going to split cos and change sine. And what that looks like is we have cos of theta minus 20 degrees would equal sine of 90 degrees minus, and that angle that was there, theta plus 40 degrees. Simplifying this, we get cos of theta minus 20 degrees, which is fine, that's what we had. And now we convert this over. Now, we see here that sine of theta plus 40 degrees is in the first quadrant, and sine is positive there. So therefore, our answer would be a positive cos of, and now you simplify what's in the brackets over there. So if you had to distribute this negative in, you'd get minus theta, and if you had to distribute the negative in there, you'd get minus 40. So that essentially becomes 90 degrees minus theta minus 40 degrees. And what that simplifies to is cos of 50 degrees, because 90 minus 40 minus theta. And here on the left, naturally, we get cos of theta minus 20 degrees. Now, we have 2 angles. One on the left, theta minus 20 degrees, and one on the right, 50 minus theta. If you recall, when we did general solution in class, we would have something typically like theta is equals to shift cos of something. And we would look at the right hand side to determine the positive or negative. Well, as you can see here, we have cos of 50 minus theta. It's a positive cos. So therefore, what we are actually going to look at, we are not going to shift cos now. What we're going to look at is we're going to see, we need to look at where cos is positive. So that would be in the first and the 4th quadrant. Alright, and what are the angles that we are working with? Well, firstly, our angle on the left here is theta minus 20 degrees. And in the first quadrant, that would simply be our reference angle here. So that is now 50 degrees minus theta. And of course, we carry on with our general solution. So plus k times 360 degrees. They have not given us any limitations. So where k is an element of integers. Now let's get theta alone. What I mean by that is literally solve for theta. So you take theta to the left and numbers to the right and solve. Alright, so we're going to get 2 theta equals 70 degrees plus k times 360 degrees, where k is an element of integers. And to get theta alone, we divide everything by 2, so theta would equal 35 degrees plus k multiplied 180 degrees. And for the fourth quadrant, we would have our reference angle, which is theta minus 20 degrees, would equal, fourth quadrant is 360 degrees, minus that angle, which is 50 degrees minus theta, plus k, multiplied with 360 degrees, where k is an element of integers because they do not give us any limitations. Cool. Now, simplifying this, let's check it out. We get theta minus 20 degrees would equal 360 degrees minus 50 degrees plus theta plus k times 360 degrees. And I'm not going to take this further. Let me explain why. So what we can see here is we have plus theta and we have plus theta. And if we took this plus theta to the left, like we did on the top, we would have theta minus theta, which means thetas cancel out and we no longer have an angle to work with. So that is not applicable. We will have no solution there. And that's it. That's the end of this problem. Now to see where you would get marks here. Well, firstly, you would get marks for isolating the cos. Then the next 3 marks would be for your first quadrant. So you would get one for saying, well, our entire initial statement there, and by remembering that we are working with plus k times 360 for the general solution. Mark number 4 comes in where you state that. And then the next 2 marks would come by making your original statement for the fourth quadrant. And your final mark comes by seeing that the fourth quadrant is no longer applicable. So your final general solution is that. Let's push on. Now we move over to the geometry side of things. We have question 6, which says, in the diagram, O is the center of the circle. Chord AC is perpendicular to radius OD at B. So AC is perpendicular to OD at B. Alright, then they say OB over here is 2x units, and AC over here is 8x units. Okay, so they haven't given us the 8x units, but they did state it. Then it says show the length of BD, so the little side over here, is 2x root 5 minus 1. Okay, this is a famous geometry question where we need theorem 1 to do this. And this question will count a total of 5 marks. Alright, so our first statement would be getting this AC and showing that AB is equals to BC. So let's start with that. We could say that AB is equals to BC. Why? Well, we could also say equals 4x. Why? Well, do we not see that we have a line from center perpendicular to chord? That was theorem 1. Okay, cool. So now we have AB is equals to 4x and BC equals to 4x. Okay. Now, very cool thing I want to show you. If I can get a OC, I technically have the total length of OD. Why? Because they are radii. So, very important statement and reason. We can use Pythagoras to do this, and every time we use Pythagoras in geometry, we have to use the reason Pythagoras. So let's write this down. We have OC squared equals to OB squared plus BC squared. Pyth. Very important. You could lose a mark for not writing Pyth. Alright, so OC would equal the square root. Please use brackets here. I have noticed, especially with my students, that when you don't use brackets, you make silly mistakes. Alright, so we have 2x squared plus 4x squared. And you'll see what the brackets actually do for you, because a lot of people are forgetting to square the 2 and the 4. This becomes 4x squared plus 16x squared, which essentially becomes the square root of 20x squared. Simplified, that becomes 2 root 5x, and the x is outside. Alright, if you type in root 20 in your calculator, you'll see you get to root 5. Alright, that is very important. Every single paper are marked with a similar question. The people got different things at this Pythagoras because they forgot brackets. So here we get 2 root 5x. Now, what we can see is that the radius or the radii are equal. So we can say, well, OC is equals to OD, and what would my reason be? Radii. Right? So that means OD is equals to 2 root 5 of x. Now, what you need to see is the whole line OD is actually equals to OB over here, so 2x plus this BD. Right? You don't even need a reason, it's just co-linear points, it's lines on the same line. Alright, so let's write that down. Let's say, well, BD, just going to write it the other way around, is equals to OD minus OB. Cool. Which equals essentially to 2 root 5 of x minus 2x. And if you had to factorize that, take a 2x out, what are you left with? Root 5 minus 1. Is that not your proof? It is indeed. So, marks. First two, theorem 1. Second one, with your reason, is Pythagoras. Third one is for radii, and fourth one is for your simplification. Sorry, fifth one is for your simplification. And there's 5 marks. We now get to the Euclidean geometry, or the second Euclidean geometry question, question 7. Now, question 7 over here would count, the first part would count 7 marks, 3, 2, and 2. Let's read through it quickly. In the figure, QS and PR are diameters. So if you go through that, QS, PR, diameters of the circle with center 0, such that PQ is parallel to SR. PQ parallel to SR. Cool. PS is produced to T. PS produced to T. N is a point on the circle such that, so N is formed such that Q1 is equals to Q2. That's it. So N is here because that halves that angle, okay? And SN is drawn. SN connects that. RS intersects QN, so RS over here intersects QN at point M with 1, 2, 3. And S1 is equals to 48 degrees. Okay, cool. Let's quickly write that one in, 48 degrees. Now, they gave us really important information that's not on the sketch, being Q1 equals Q2. So go and draw that in immediately. Another nice thing you can draw in so long is your radii. Okay, OP, OQ, OR, and OS. Those 4 sides are equal in length. Alrighty. Now, before we look at the questions, let's go through our roadmap. If you don't know what I'm talking about, you can go check it out on the whiteboard, Tutoring SA. We have a roadmap to geometry problems. Just a nice place to start and where to go. We look at the center point theorems, the cyclic quad theorems, and then the tangent theorems. Let's start off with the center point theorems here in blue. So we have our center point. We do not see theorem 1 anywhere. Theorem 2, we do see. However, I want to point out to you, there are no labels around point O here, meaning that our center point theorem going from Q to O and R to O, forming that angle, and then the angle at S, would not be necessary. Yes, we can see this angle is 2 times angle S3, but we don't need it. It's not labeled. The memo would generally indicate towards something else with labels. Alright? So let's jump past theorem 2. Let's go to theorem 3, which would tell us angle N, because of angles in a semicircle, is 90 degrees. Likewise, P is 90 degrees, but again, P has been split into 2 angles, and you can see we're not going to need it because of that 90 degree there. So let's leave it at. That's the center point theorems done. Let's go to cyclic quads. Cyclic quads, we can see that Q1 plus Q2 plus S3 plus S4 plus S2 would equal 180 degrees because of the opposite angles in a cyclic quad. But that's a lot to write down, so let's just keep a mental note of that. What I do want to note with you in, let's do this one in red. So cyclic quads we're going to do in red is that S1 over here is equal in size to Q1 plus Q2, that whole angle, because it's an exterior angle of the cyclic quad. That is theorem 5, and that's what we're going to need for this first question. Then we go to angles in the same circle segment. I'm going to use my highlighter to point those out. We can see that Q1 is equals to angle R because of angles in the same circle segment. Likewise, I'm going to have to change to a bit of a different color here. We have in green, P would equal S3. Alright. Now let's go to tangents. And something I noticed with some of the grade 11s that have written this in a test is the assumption of a tangent line. Now let's read this quickly. PS is produced to T. Doesn't say to form a tangent. Nowhere does it tell us that PST is a tangent line. I mean, it cuts the circle at 2 points, which means it's a chord. So we do not have any tangents. No tangents. This is not a tangent. If you were thinking it's a tangent, stop thinking that, please. That's haha. Okay, it's not a tangent. It cuts the circle at 2 points. So we now look and see that we have no tangent theorems for this question. Then we need to go look at parallel lines. We need to go look at triangles or intersecting lines, right? Now, parallel lines will tell us alternating, corresponding, or co-interior lines. And because of that, our green dots suddenly turn red. Well, why? If you look here, you'll see R is equals to P because of alternating angles. P was equals to S3, so now all of these angles are actually equal in length. And that's kind of where we want to build up to with our roadmap, is we want to discover how many angles are equal to a different angle because of two or more reasons building up to that point. And then in triangles, well, you can see that we would have sum of angles in a triangle here for S2, M1, and 90 degrees. Let me change that color to not get confused with the other angles. So let's do yellow dots, just to keep a mental note of it for now. And so on and so forth. You can also see that we're working with exterior angles of a triangle here. So if you had to look in this triangle QSM, you'd see M1 forms the exterior angle of that triangle. The reason I'm pointing that out is question C over here. Says we need to look at M1. So keep that in mind for now. M1 would equal Q2 plus S3 because exterior angles of a triangle. Alright, so let's get busy. We have enough information to answer all the questions. Let's start with Q1 for 3 marks. Now, as you remember, I mentioned to you that angle S1 would equal Q1 plus Q2. It is equals to the entire angle. And what is our reason for that? That is the exterior angle of a cyclic quad. Alright, S was 48. But now we remember that Q1 is equals to Q2. Why do I say that? It's given to us. So our reason there is given. So therefore, if 48, S1 was 48, 48 degrees is equals to Q1 plus Q1. So 48 degrees is equals to 2Q1. 24 degrees is equals to Q1 angle. Okay, does that make sense? What we did actually was we replaced the Q2 with Q1 because they are the same thing. And then we solved it and we got that. Alright, that's 3 marks. Your mark allocation here, obviously for your first statement. Ooh, that is a terrible color to be marking with green. There we go. We have our first statement, we have our second statement, and we have our solution. 3 marks. Alright. Now before going on, let's just write this in quickly. 24 degrees, 24 degrees. Alrighty. Now, for the second one, they want us to solve for angle R. Okie dokie. Let us get started. So, angle R we mentioned was equals to angle Q1, which is now been solved as 24 degrees. What would our angle be there? Well, those are angles in the same segment. That is theorem 6. So R here is 24 degrees. 2 marks, 1 for statement, 1 for reason. And now for angle M. And I told you to look out for this one in the exterior angles of a triangle. There are various ways of doing this, but the easiest is to see the exterior angle of a triangle one. Now, if you see, we have S3 is actually equals to angle R. And something I didn't mention before, but I'll mention now, is we have an isosceles triangle here. We have the radii of OR and OS. So then S3 would equal angle R. And M1, and of course angle R is equals to Q2. So therefore M1 would equal S3 plus Q2 because of exterior angles of a triangle. Let's write that down quickly. Okay, so we have, before we say S3 is equals to R, we can actually say that side OS equals OR because of radii. That is an important statement to make, you can't just assume it. So therefore angle S3 is equals to angle R, and that would be angles opposite equal sides. And then we can say, okay, cool, so angle S3 is equals to 24 degrees. Now, for the triangle, I'm going to highlight this again in yellow. For this triangle over here, we have M1 as an external angle. So we could say in triangle MQS, dot dot. M1 would equals to angle Q2 plus angle S3. And our reason there would be exterior angle of triangle. So therefore M1 is equals to 24 plus 24 is equals to 48 degrees. Okay, there are a few different solutions for this problem. This one I found was the easiest. So your first statement here, or your first mark would be for finding that S3 is 24, and your second would be the exterior angle of a triangle solution. Alright, let's push on. Our last question with this circle is that they have asked us, so you'll see it's the same question as before. It's question 7.2. Figure QS, PR are diameters of the circle with center O, and is produced to T. N is a point to the circle that Q1 equals Q2 and Sn is drawn. Now the question itself would be prove that ST is a tangent to the circle passing through MN and S. What that essentially means is now there is a new circle. Please do not think that ST is a tangent to the big circle. No, it's a tangent to this new smaller circle. Alright? And if you recall, we just solved that Q1 was 24 degrees, this was 24 degrees, M1 was 48 degrees, R was 24 degrees, S3 was 24 degrees, and P was the same as them all. Alright, now, if we are proving that a line is a tangent, you need to look at the converse of theorem 7 or 9. Okay, and what we can see we need here is actually, it's theorem 9. Let me show you why. Because if this is going to be our tangent line, if PS over here is going to be a tangent line, then we need to consider a chord for theorem 9. Alright? Line between tangent and chord. And if we can prove that S1 is indeed equals to M1, then it is. Because, why? As you'll see, or as you'll recall from one of the videos earlier on the whiteboard channel, if we look at the line between the tangent and the chord, and we put our finger here, we go up, and we have one finger that stays here, and then we close that angle on the circumference of the circle. If that angle equals this one, it's the converse of theorem 9. We've already proven that M1 is 48, and S1 was given as 48 degrees. So we can make a statement here, and we can say, well, S1 is equals to M1 is equals to 48 degrees. That is proven. Alright? We've proven M1, S1 was given, that's fine. And now we can say, well, therefore, PST, or in this case they just asked for ST, is a tangent, and our reason would be the converse of theorem, converse of the tan-chord theorem, converse tan-chord theorem, or alternatively a better reason actually would be angle between line and chord. So angle between line and chord. Okay, let us move on to the last question. Before we do that, 2 marks, statement, reason. Before we do that, 2 marks, statement, reason. For the final question of this paper, we have the following circle given, and please note it is 6 marks. Alright, so the question reads, O is the center of the larger circle RTAP, so we have a larger circle with a center. OP is the diameter of the smaller circle. It's also the radius of the larger circle. NP is tangent to both circles. Okay, NP is a tangent to both, which is good news. Rn, so Rn is perpendicular to NP, and let P1 equals X. P1 equals X. This is P1 over here. Okay. Prove that PR bisects ORN. You should have done your roadmap by now to mark all the angles that are equal, but there is one thing I do want to point out. It says prove that PR bisects ORN. What that means is they want us to prove that R1 is equal in size to R2. As soon as you get that, you're good. And you don't have to find values for them. You can solve them in terms of X. Okay? So, I just want to start off before we even do our roadmap and show you that using the sum of angles in a triangle, angle R1 plus angle N plus angle P1 would equal 180 degrees. With our reason being sum angles in triangle. Right, sum. Now, we have R, so let's say R1. Angle R1 plus 90 degrees plus X equals 180 degrees. Therefore, angle R1 equals 180 degrees minus 90 degrees minus X, which equals 90 degrees minus X. Okay, that's R1. Now, if we can get R2 to be the same as R1, we answer the question. Alright, that is the ultimate goal. So let's take a look here. We've got R2. Now, if you look with me, you should have gone through the roadmap with all of these sides, but you'll see that OR and OP are equals to each other. Why? They are radii. Then you can see that P2 over here is equals to R2. And why is that? Angles opposite equal sides. And P, I've done it here in blue. If you see, P1 and 2 is 90 degrees. Why? Well, this is a radius, That's a tangent, so radius perpendicular tangent. P2 alone would be 90 minus x. So R2 is 90 minus x. Here you go. Let's write it out quickly. Alright, so we can say that angle P1 plus angle P2 would equal 90 degrees. It would be radius perpendicular tangent. Alright, and then we could say, well, P1 is x. So that's x plus angle P2 equals 90 degrees. So angle P2, through manipulation, is 90 degrees minus x. But OR is equals to OP. What's my reason for that? Radii. Therefore, angle P2 is equals to angle R2. So that is a 2. P2 is equals to angle R2. What is my reason there? Angles opposite equal sides. And that is angles. Alright, fantastic. What did we just say P2 was? We just said P2, which is now R2, is equals to 90 degrees minus x. So we have R1 equals to R2, and therefore we've answered the question. Mark allocation. Remember, this is 6 marks. There are many different ways of solving this problem. This is the best and easiest way. It's just to get R1 and R2. This is also the way we teach on the whiteboard. Okay, so 2 marks for sum of angles in a triangle for R1. Then you get another mark for your statement that P1 plus P2 is 90 degrees. That's 3. Then you get a mark for saying OP equals to OR is radii. That's 4. Angles opposite equal sides. That's 5. And your last statement replacing them, which is 6 marks. That is 50 marks. I hope you enjoyed watching this video. Please like, subscribe, and share with your friends. They might need this help. It helps us create content, and it would be fantastic to have you join the whiteboard essay.